surviving in the wild takes a little something extra. After all, it's a jungle out there. That's why some animals have special abilities to see, hear, and even taste the world in ways we can barely imagine. You might say they have a sixth sense. There are a lot of fish in the ocean, but with all that space to hide out, they're not always easy to find. But a master predator like the shark has special ways to track down its next meal. Take their amazing sense of smell. Sharks can detect a drop of blood in a body of water the size of an Olympic swimming pool. And they're not just following their noses.
They actually have scent receptors not only at the front of their nose, but along the side of their body as well, and taste receptors there as well.
That's why sharks sometimes bump before they bite. And that's not all. Sharks have a built-in radar system. All living creatures give off low-level electrical charges, and sharks have a sixth sense, the ability to detect those electrical fields. See those dark spots on the shark's face? It's a sensory network called the ampullae of Lorenzini. Those pores open up to gel-filled canals under the skin, filled with nerve fibers that conduct electrical impulses to the brain. Sharks aren't the only electroreceptors in the sea, but they're far and away the best. Animalscience Award! Sharks are about 5 million times more sensitive to electricity than humans are. Even a flip of a fin generates a charge big enough to show up on a shark's personal radar. That extra edge is what keeps sharks at the top of the underwater food chain. Dolphins have a remarkable ability to use sound to actually see underwater, using a skill called echolocation. Dolphins don't have vocal cords like people. They produce whistles and clicks using nasal air sacs located below their blowholes. With echolocation, dolphins use those noises to paint a picture. They send waves of sound through an area of fatty tissue in the forehead called a melon. When the sound waves hit something, like a boat or a school of fish, they bounce back, carrying information about the size, shape, movement, and distance of whatever it was they hit.
So the sound hits the lower jaw and travels up the lower jaw to the inner ear and then into the brain, where they're able to form a mental picture of whatever the object was that was in front of them.
Echolocation lets dolphins see by hearing, even in the dark. Now that's what you call using your melon. Butterflies are some of the most colorful creatures on Earth. Their wings are actually translucent. The colors and patterns come from thousands of tiny scales arranged in overlapping rows like shingles on a roof. Some are pigmented. Others create color by refracting light, like a rainbow. But there's more to a butterfly than meets our human eye. Butterflies have a super secret power. The ability to see ultraviolet colors. It's a whole spectrum beyond your ordinary red, blue, or yellow. UV light is invisible to the human eye. Flowers use ultraviolet colors and patterns to write hidden messages. And the James Bond of the insect world can read them.
To a human eye, the flowers just look pretty. Under UV light, a flower can look very different. They actually have almost like landing strips to let them know exactly where the nectar is. That is beneficial to the butterfly because then they know exactly which flowers they should be eating from.
So the next time you see a butterfly flutter by, remember, it sees a whole different world. And it's probably following an invisible ultraviolet roadmap to its next meal. When we return, you'll learn why a skunk can frighten a bear with just a wave of its tail, and how a stingray protects itself when it's buried in the sand. We look at animals' built-in defense systems right here on Animal Science. Some animals just want to stay out of trouble. But secretly, they're packing quite a punch. If you leave them alone, they're as mild-mannered as Clark Kent. But challenge them and watch out. They may look as cuddly as a teddy bear, but even real bears know that skunks can make quite a stink. And that message couldn't be clearer.
Skunks have stripes because it's basically like a warning strip to let a predator know, if you follow the strip from my head down to my tail, at the end of my tail is where you're going to get in trouble.
Under its tail, a skunk has glands that can spray an oily yellow liquid as far as 10 feet.
The skunk's spray. It's a smell that is a combination of rotten eggs with burnt rubber, with urine.
Skunks only carry a small supply of spray, and it takes up to 10 days to replenish, so they'll give you plenty of warning before cutting loose.
They will stomp their feet, they'll lift up their tail, they'll start backing into the person, just as a forewarning. They really just want to use that spray as a last resort.
So if a skunk turns its back on you, just say, "Smell you later." Then turn your own tail and run. Meet the armadillo, a bright-eyed creature that looks like a cross between a turtle, an armored tank, and an accordion.
This is the regular skeleton of the animal. You can see that this part here is essentially the armor of the animal above the tops of the spine. Right between these 9 bands here is where it's flexible.
That's the accordion part. The armadillo's shoulders and hips are well protected, while the flexible bands let it twist and turn to its heart's content. An armadillo's only area of vulnerability is its unprotected underbelly. But most species of armadillos can shut down an attack by rolling themselves into a ball. Any animal looking for an easy snack could bust a tooth trying to bite down on a jawbreaker like this guy. A stingray on the move is an awesome sight. Their wave-like motion makes it look like they're flying underwater. A stingray at rest? They'd rather blend in to hide from predators. But if threatened, the stingray's got a weapon that even makes sharks back off. A poisonous barb at the end of its tail, which it can swing over its head like a medieval weapon. The barb is shaped like a Christmas tree with serrated edges and a sharp point. But the only things underneath this tree are grooves filled with a protein-based venom.
They're bottom dwellers. So if a stingray were to get stepped on, that's when people usually end up getting injured by them. Normally, it's not life-threatening unless that barb is able to hit a vital organ like your heart or your lungs.
Stingrays don't want to be stepped on any more than you want to surprise them. To avoid any painful encounters, do the stingray shuffle. Drag your feet along the ocean floor. The rays will feel the vibrations and pack up to find a more private spot. When we return, we'll look at horses and zebras, members of the same family, but oh, so different. We'll find out why one was born to giddy up, while the other was born to be wild. Right here on Animal Science. On the surface, horses and zebras are equines with a lot in common. But horses have been working for a living for thousands of years, while zebras roam African plains and woodlands. Why is one domesticated while the other runs wild? Zebras and horses look a lot alike, and they're both part of the equine family. And it's a big family. Zebras have only 3 species, all found in Africa, but hundreds of breeds of horses can be found throughout the world. Bred for specific jobs over the centuries, horses vary tremendously in colors, shapes, and sizes, from small shaggy ponies to leggy thoroughbreds to giant-sized draft animals. But zebras aren't just horses that forgot to take off their striped pajamas. In fact, their differences are more than skin deep. Zebras have a different number of chromosomes, the cells carrying DNA, which contains their genetic blueprint. And those blueprints explain why horses get the rent paid while zebras roam free. From tempers to tails, they're constructed differently. Zebras aren't adapted to the working life. For one thing, zebras aren't built for a saddle. Compared to a horse, a zebra has a shorter neck and back and a straighter spine.
The way the vertebrae are formed on the zebra, it's not as comfortable for the zebra to carry weight on its back.
A zebra's gait is choppier than a horse's, so it wouldn't be a smooth ride for a passenger either. Horses are generally better runners than zebras. They're sleeker and faster. That might be why they react differently to stress. In a fight or flight situation, both zebras and horses will flee as their first line of defense. But pushed into a corner, the zebra is more likely to fight back.
The zebra is much stronger in his neck. They fight with their feet and with their mouth, so you can be injured very quickly.
That's not a quality you want in an equine companion. Domesticated animals need pleasant dispositions if they're gonna hang around humans, which is why you're never gonna see anyone walking a pet grizzly bear. Horses have coexisted with people for generations, but even a tame zebra is still a wild animal at heart. When we return, you'll find out what the manatee's sensitive whiskers are really used for. And you'll learn why a sloth's fur has a green tint when we look at the slowest animals on the planet, right here on Animalscience. If the fastest animals on the planet held a race, it would be over before any of these guys even reach the starting line. When it comes to swimming, climbing, or even eating, their motto is, easy does it. The three-toed sloth moves at a top speed around 0.15 miles per hour, making it the slowest mammal on the planet. Animalscience Award. Sloths spend their lives just hanging out upside down in trees. The plant-eating sloth is so slow that other organisms set up camp in its fur.
Their bodies actually provide homes for cyanobacteria, which are a kind of photosynthesizing organisms. So essentially the sloth becomes a kind of forest, possibly by virtue of the fact that they don't move around very much.
Cyanobacteria give the sloth's fur a greenish tint. And it turns out there's an advantage to looking like a bunch of leaves. Camouflage.
Their major predators are visually hunting animals. If you have green all over, you may not be spotted when you're in the trees.
So if you're trying to catch up with a three-toed sloth, try looking in the last place you saw it. Chances are that sloth is still hanging around. If sloths are the slowest mammals on land, manatees take the water award. They float along at speeds as fast as 5 whole miles an hour. Hit the brakes, guys. To find food, they follow their whiskers, 2,000 stiff hairs called vibrissae, and they're as sensitive as a fingertip.
It helps them to feel where they are, helps them for differentiating different kinds of plant material before they actually eat it. So they're more than just a regular whisker.
Because they're constantly grazing, manatees have been nicknamed sea cows. But their real kissing cousins? The elephant. What? You don't see the family resemblance?
A manatee's mouth actually has a lot of muscles in it. They use it to be able to pull plants and material into their mouths, very similar to how an elephant will use its trunk.
So maybe instead of a sea cow, manatees should be called water elephants. Kinda got a ring to it, don't you think? What if you had to eat the same exact meal day in and day out? That's how it is for koalas who live in eucalyptus forests in Australia. All their food and even their water comes from leaves and bark. And they have adapted to their unique diet in very special ways. Koalas have one of the slowest metabolisms of any mammal. Because there's so little nutrition in eucalyptus leaves, koalas conserve their energy by sleeping up to 18 hours a day. And then there are those great big noses.
They need to be able to have a very good sense of smell so they know they're eating the right plants so they don't poison themselves as they eat.
Did you say poison? That's right. Eucalyptus is toxic to most animals, but koalas stick to the less poisonous varieties. So if you ever invite a koala for dinner, be sure there's plenty of eucalyptus on the menu. And save a little time for that after-dinner nap. It'll probably last until lunch. When we come back, you'll learn about the tricky climbing mechanics of the squirrel and how a 600-pound bear claws its way to the top. When we look at the best climbers on Animalscience. It takes a lot to reach the top, and these intrepid creatures aren't afraid to scale the heights. That's because they have the right equipment to take them all the way. Squirrels are the daredevils of the upper levels. They can be found on every continent except Antarctica. Where are they? Look up. They love a branch with a view. For most species of squirrel, half their length is their bushy tails, which help them steer and balance, the way gymnasts use their arms on a balance beam. The squirrel also has double-jointed hind legs. Doesn't sound impressive? Try it for yourself.
They can basically take their hind legs and rotate their feet around. It's the comparison to taking your feet and turning them so your feet are completely backwards while you're facing forwards.
The ability to turn its legs 180 degrees lets a squirrel scamper down a tree head first. That's what makes squirrels the top treetop acrobats. Black bears can fool you. They can weigh as much as 600 pounds, but like the tiny squirrel, they love to leave the ground behind.
Black bears are really known for climbing trees. It's a way to get up to leaves and berries and things that they want to eat. For cubs, it's a way to have safety.
Black bears have equipment that any mountain climber would envy. Each toe is topped with a powerful and non-retractable curved claw that lets them dig into the bark. Black bears are also excellent swimmers. If there's ever an animal triathlon with running, swimming, and tree climbing, bet on the black bears to win. They've got the right stuff. From Animal Science, see you next time.